Good day. This is Anton Chris Lim of ENS 201 reporting on ozone depletion, which is a hazard in our environment right now. First off, I would like to introduce certain topics or certain terms that are very essential in the report. We have ozone. The ozone is a molecule consisting of three oxygen atoms. Ozone gas can be created or destroyed by the sun's ultraviolet rays. It is a bluish gas that is harmful to breathe. It is absorbed it absorbs a certain band of ultraviolet rays which are harmful to life. Nearly 90% of the Earth's ozone is in the stratosphere and is referred to as the ozone layer. As mentioned, ozone layer is a layer of gas consisting of these O3 molecules called the ozone that forms when a free oxygen molecule bound to O2 molecules creating an O3 molecule. The ozone layer is a protective layer of gas molecules located within the stratosphere. Ozone gas also exists in the troposphere and at ground level, but most is located within the stratospheric layer. Why is it important to life on Earth? On a daily basis, the sun radiates its energy toward Earth. One form of this energy is ultraviolet radiation, also known as UV rays. UV rays are relatively high energy waves that provide Earth with the warmth it needs to support life as we know it. That is actually on the positive side, but as we go on with this report, I'll be tackling the three types of UV rays, which are not all beneficial to life here on Earth. UV rays penetrate the Earth's atmosphere at three slightly different wavelengths. As I mentioned a while ago, there is UVA rays, which are most common and cause skin aging and wrinkling. Tanning beds are usually used these types of rays. UVB rays cause sunburns, cataracts, and immune system damage. And the third kind is UVC, which are most dangerous and usually absorbed by our ozone layer. Why is the ozone layer important to life on Earth? The stratospheric ozone layer completely stops the penetration of UVC rays and eliminates most of the UV rays. As mentioned a while ago, these UV rays are harmful if not detrimental to life. Therefore, the ozone layer protects life on Earth from the harmful effects of solar radiation on a daily basis. How are we as humans affecting the ozone layer? Since 1928, chlorofluorocarbons have been produced originally as non-flammable refrigerants for use in refrigerators and eventually for use in fire extinguishers, dry cleaning agents, pesticides, degreasers, adhesives, and as propellants for aerosol products. As the CFCs has been released into the atmosphere, the level of ozone in the stratosphere has decreased. CFCs have an estimated lifespan of more than 100 years. So, if these kinds of harmful gases are released in the environment, it would take a century for us to remove, if not cleanse, the atmosphere of these harmful gases. These are also ozone depleting substances. We have CFCs, HCFCs, halogens, methyl bromide, carbon tetrachloride, and methyl chloroform. Now, these gases affected the ozone layer and creating a hole. Since the 1970s, the ozone hole has been increasing in size over the Antarctic. For the first time in September of 2000, the ozone hole became so large it actually left populated areas of southern Chile fully exposed to effects of the sun's UV rays. Now, the question would be, how does ozone depletion affect global warming and ultimately climate change? As ozone levels in the stratosphere are depleted, more solar radiation penetrates the Earth's atmosphere, exposing us to solar radiation, also adding the increase in surface temperature. Global warming actually results in warming of the troposphere, but the cooling of the stratosphere, hindering the ozone layer's natural chemistry for repairs. What are we doing about it? After the discovery of this ozone depletion in the 70s, countries agreed that there will be a worldwide stop to the production of the man-made ozone harmful products. The international community adopted the Vienna Convention in 1985, followed by the Montreal Protocol in 1987. The latest reports confirm that it has led to the phasing out of about 95%, which is very good, on the consumption of ozone depleting substances listed in the agreement. In turn, this had led to the prospect of the ozone layer recovering as expected by 2050 to 2075. The phasing out of these ozone depleting substances has helped to fight climate change since many of these chemicals are also powerful greenhouse gases. In a recent study, the phasing out of substances under the protocol led to more reduction in greenhouse gases than what is foreseen under the Kyoto Protocol. As concerned citizens, we should make sure that technicians working on your car, air conditioner, or refrigerator are certified by an EPA approved program to recover the refrigerant. And if I'm not mistaken, certain refrigerants that pass these certain programs are to be utilized only, not the old ones that are detrimental to human beings as well as animals, mostly life. Have your car and home air conditioner units and refrigerator checked for leaks for these harmful gases can be left out of the atmosphere roaming around us. If consumed or inhaled, it will be a problem. Repair leaky air conditioning units before refilling them. Contact local authorities to properly dispose of refrigeration or air conditioning equipment. For old and obsolete air conditioning units can still have these harmful gases. Protect yourself against sunburn. Minimize sun exposure during midday hours, 10 a.m. to 4 p.m. Wear sunglasses, a hat with a wide brim, a protective clothing with a tight wave. Use a broad spectrum sunscreen with a sun protection factor of at least 15 to 30 if better. Now, since we all led to believe that these are only ozone depletion is a problem, there is also one topic that I would like to introduce, which is ground level ozone formation. This is caused by secondary pollutants that I will discuss later on. We have VOCs, which are volatile organic compounds, NOx, also known as oxides of nitrogen. This is VOCs plus oxides of nitrogen that goes to the ozone in presence of sunlight. Ozone plus oxides of nitrogen plus Hydrocarbons will produce smog, which is detrimental to people. It does not only destroy the atmosphere, it also kills life here on Earth. Photochemical smog. Photochemical smog is a good example of a secondary pollutant, which is a product of smog. Smog is a pollutant given off by burning fossil fuels. Now, photochemical, on the other hand, is the chemical reaction by sunlight, nitrogen oxide, and volatile organic compounds in the atmosphere, which leaves airborne particles and ground level ozone. These chemicals are toxic. It is very prominent as the day goes on from 6 a.m., as you can see, 12 noon, up to 3 p.m. You also have smog sources. VOCs, oxides of nitrogen and VOCs from refineries, chemical plants, cars, and factories go straight to the ozone layer. Now, some of the oxides of nitrogen from trucks, buses, and non-road equipment, as well as power plants, go directly to the ozone layer. But diesel particles, sulfur dioxide, and particulate matter go to the smog and eventually goes to the life on Earth, which as air pollutant is very detrimental. You have sources of volatile organic compounds. VOCs comes from motor vehicles, which constitute 30%, consumer solvents, which adds 5%, and a big part of that comes from industrial commercial processes. Oxides of nitrogen comes from motor vehicles on a 49 percentage. Fuel combustions constitute two parts, which are utilities, the production of electricity, provision of water, which has 28%, and industrial, commercial, residential, which gives 13% of this oxide nitrogen. But fuel combustion in itself has a combined 41%. 5% goes to other sources. What can we do about it? Keep your automobile well tuned and maintained. Carpool. It can be arranged in offices, places where you can use only one vehicle instead of one individual with one vehicle is very much non-beneficial to our atmosphere. Use mass transit, walk, bicycle, and reducing driving, especially on hot summer days. Be careful not to spill gasoline when filling up your car or gasoline-powered lawn and garden equipment. Everything that deals with gasoline. During summer, fill your tanks during the cooler evening nights where there are no chances of these gases actually exiting our atmosphere. Make sure that your car tires are properly inflated and your wheels are aligned, because consumption of tires also produces these detrimental gases. Participate in your local utilities energy conservation programs. Seal containers of household cleaners, workshop chemicals and solvents, and garden chemicals to prevent VOC from evaporating into the air. Dispose of them properly, because most people would neglect disposing it properly, thus releasing these harmful gases in the atmosphere. Thank you very much. And as this report ends, parting words would be, if you take care of nature, nature will take care of you. Thank you very much.